Hi, welcome to one and all. Next we will discuss about theorem 8.8. The statement is let f be completely multiplicative and let g of k is equal to mu of k h of k, which is multiplicative. Assume that f of p not equal to 0 and f of p not equal to h of p for all primes p, and let sk of n is equal to sigma d divides gcd of nk f of t g of k by d. Then we have sk of n is equal to capital F of k g of capital N by f of capital N, where f is the convolution f star g and n is equal to k by gcd of nk. Here f is given to be completely multiplicative. Completely multiplicative means f of mn is f of m times f of n, where m and n can be any integers. And f is multiplicative means f of mn is f of n only when m and n gcd of m and n is equal to 1. So here h is multiplicative and f is completely multiplicative. So now let us come to the proof. Here we have f of k is the convolution function f star g, which is f star g of k is sigma d divides k f of t g of k by d. But g of k is given to be mu of k h of k, so we can say that f sigma d divides k f of d g of k by d can be written as sigma d divides k f of d mu of k by d h of k by d, because d of k is mu of k h of k. Now since this is an convolution, we can replace this d by k by d and k by d by d, so that we are doing this here, and we will get sigma d divides k f of k by d mu of d h of d. Now since f is completely multiplicative, so f of k by d times f of d is f of k, so f of k by d can be replaced by f of k by f of d. So if we replace this f of k by d by f of k by f of d, we will get f of k capital F of k equal to f of k times sigma d divides k mu of d h of d by f of d. Now this we have studied earlier. We have studied one result that sigma d divides k mu of d h f of d is product p divides k 1 minus f of p. So here we can treat this function as h by f can be treated as a function, multiplicative function. So here this can be, we will apply this result, and thus we will get f of k times product p divides k 1 minus h of p by f of p. Now we will apply this result later on, and now let us come back to our result again. We have given that n is capital N is k by n gcd of nk, so we will take this gcd of nk as a, then we can get a equal to, if we replace this as gcd of nk, then k is equal to an. So sk of n, by the definition of skn we have sigma d divides a, that is d divides nk, and f of d mu of k by d h of k by d. So here this k is replaced by an, so this will become sigma d divides a f of d mu of an by d h of an by d. Now again we will use the property of convolution of the Dirichlet function, that is here a this d is replaced by a by d and a by d by d. So we will get sigma d divides a f of a by d mu of nd h of nd. Now this mu of nd is equal to mu of n mu of d, because this is mu is multiplicative. So if nd is gcd of nd is equal to 1, then mu of nd is mu of n mu of d, and if mu of nd is equal to 0 if nd is greater than 0. So this is a result you have studied earlier. So by using this result, we can write this as, here mu of nd can be written as mu of n mu of d. So this mu of n is taken outside, and here from here mu of dn h of n is also taken outside, and remaining terms are sigma d divides a n gcd of nd is equal to 1 f of ad mu of d h of d, and this is f of, here again we use f of a by d can be replaced by f of a by f of d. So this f of a is taken outside, and f of a mu of n h of n sigma d divides n, and d equal to 1 gcd of nd is equal to 1 mu of d h of d by f of d. Again we can use the result which we have already obtained. that f of a is this result. By using this we can write f of a mu of n h of n is written here. Now this is product p divides a. P does not divide n because GCD of nd is equal to 1. We can say that p does not divide n. So 1 minus h, this is 1 minus h of p by f of p. Now here there are those products 1 minus h of p by f of p where p divides a but p does not divide n. So this can be rewritten as f of a mu of n h of n product p divides a n 1 minus h of p by f of p by product p divides n 1 minus h of p by f of p. That is, if we remove the products p divides n from the products p divides a n, we will get the products where p does not divide n. So that is why we have replaced this like this. Now this we have already proved what it is. If this p divides an is nothing but it is k. An is k. We have already written as an as k. So here this is p product p divides k 1 minus h of p by f of p. Here this product p divides n 1 minus h of p by f of p. So here we can apply the result which we have proved earlier. F capital F of k is equal to small f of k by times product p divides k 1 minus h of p by f of p. So this can be f k by f k. So this product is capital F k by small f k. So we will replace here as capital F of k by small f of k, and in the denominator also we have p divides n, product p divides n. So this can be written as capital F of n by small f of n, which will be in the numerator, small f of n. So thus we have capital F of n is f of k is here, mu n is here, h of n is here, and the remaining f of a is taken out here, and this f of n. Now this f is multiplicative, so f of a times f of n can be written as f of a n. So we have written it as f of a n because f is multiplicative. So we have written it as f of a n. Now this f of a n is nothing but f of k. So capital F of k mu of n h of n f of k divided by capital F of n f of k. So this f of k is cancelled and we will get f of k capital F of k mu of capital N h of capital N by f of capital N. This mu of n, mu of capital N, h of capital N is nothing but g of capital N. So this is f of capital F of k g of capital N by f of n. Thus we have proved the result. Now as an immediate consequence of this theorem, we can have since if we replace in sk of n the f of d by d and g of k by d by mu of k by d, we will get the result corresponding to the Ramanujan sum. Ck of n is phi of k mu of n by phi of n. So this is what we are going to get. And what is n? N is nothing but k by GCD of nk. So that we have replaced it here. Thus we obtained this example also. Hope you have understood the concept clearly. If you have any doubt, please comment me in the comment table or just leave a WhatsApp message. Thank you for your patient listening.